Den, thank you very much. Ladies and gentlemen, good afternoon, and again, welcome to the Royal Academy of Engineering for this day of celebration. We praise scientific and engineering achievements in two critical fields, the laser and fibre optics. Lord Rees is going to tell you more about the science behind these successes shortly. What I'd like to do is concentrate on the engineering aspects, for these have profound significance for us all. The laser came 50 years ago as a triumph of physics dating back to Einstein. Few realized that this heralded the creation of a powerful engineering tool, the harnessing of light for a wide spectrum of applications. We use it for machining metal slabs half an inch thick and for tailoring our suit fabrics. We can detect turbulent flow behind a landing aircraft, the streaming of a Formula One car, the variations in a landscape for satellite mapping. Tiny lasers are found in all CD players, huge ones in fusion power experiments. It's revolutionized medical diagnosis and treatment, and much, much more. Can they really have thought that it was a solution in search of a problem? Those who coined that sentiment can't have appreciated the versatility and ingenuity of engineers. Yet we engineers should accept that this progress was built on the concepts pioneered by a gifted scientist. Professor Towns, we're privileged and delighted to have you with us today. You've still got many calls on your time, even 50 years after you saw your ideas come to fruition, and we're grateful that you've shared your pleasure with us. The second achievement we recognize has more local roots, for it happened just a few miles away from here in an industrial research laboratory in Harlow, Essex, 44 years ago. There, Charles Kao had the dream of passing messages around the world in a novel way, not by wireless, not through wires, but optically. He knew that light beams in the air could never travel far enough, but decided that glass fibers might be made pure enough to keep the light in and bright for many miles. That was a revolutionary concept, ahead of its time, because the ranges then possible were pitifully inadequate. But he persisted. For many years he nagged his research managers, glass manufacturers, and telecom companies until even the harshest critic had to admit his genius. He was as concerned with the commercial realization as with the technological progress, and his personal contributions to components and systems have made possible the world's abilities to communicate freely. Professor Kao's unique achievements began to be acknowledged 10 years ago, after his initial 10 years after his initial publication, and the accolades have not yet stopped. Our own fellowship came 20 years ago, and Prince Philip personally presented him with the Academy Medal bearing the Prince's name in 1996. The following year saw Fellowship of the Royal Society. We can ponder on reasons why the award of the Nobel Prize came so much later, but of course there is no Nobel Award for engineering. We in the Academy know that the criteria we are now asking of leading engineers are demanding. They must be innovative. They must be globally aware, cooperative with fellow engineers. They must be socially conscious, economically alert, and politically sensitive. Charles Kao showed these attributes throughout his career. He's a true engineer, and today we show him how much we appreciate his talent. Thank you very much.